Good morning. So today we are going to talk about natural selection. And yesterday you watched a short video on natural selection and the scientists that were involved. Now, Charles Darwin is the one that gets most of the credit when we talk about natural selection. He was born into a family of doctors. He had a natural curiosity about things. Uh, at the age of 20, then he took off on that voyage around the world and he collected lots and lots of specimens. So if you look at what he collected, kind of he's most famous for his study on finches and iguanas, and then looking at fossils and looking at the record and how all those things are shared. Okay. Um, he had many ideas, and like they said in the video, he was kind of afraid to publish them because it went against the teachings of what was going on in the world right then. It was radical thought, and he really just wanted to preserve and protect his family and their position and all of that. So it was kind of hard for him. And so remember from the video yesterday that then the scientist Wallace came to the same conclusion separately and sent his information to Darwin. And then he kind of pushed him to publish his work. And then Wallace supported it a little while later. So we don't really hear about Wallace very much, but he was very important. So, what was Charles Darwin actually able to explain about how this evolution happened? So, people noticed that there were different organisms around, but nobody really wanted to take an explanation for it, because the kind of the teaching of the church right then was that everything was created for its specific purpose, and that was it. So, he realized that there are more species on Earth than the environment can support. So every organism kind of does this thing called overproduction. Well, not all, but a lot of them, where they make more than the environment can produce. Whether there's not enough food, or there's not enough shelter, or there's not enough of something, that they have to now compete. So the whole point of natural selection is competition within a species. And then those who are most suited or are best at competing survive long enough to reproduce. And when they reproduce, whatever trait it is that gave them an advantage gets passed on to the next generation. So then the species that are better at escaping, so whether they're better at escaping predators or finding enough food or functioning better in the climate, are most likely to survive. And he called that struggle for survival natural selection. So, natural selection, a simple definition is the struggle to survive. And then the process, but the official definition is the process through which members of a species that are best suited to their environment survive and reproduce at a higher rate than other members. So it's basically what I just explained to you, that some organisms have traits that make them better at the competition. And because they're better at the competition, they survive long enough to reproduce. And then in the next generation, there are more of that trait. Okay? So let's look at an example. Okay, and that's hard to do when you're at home, but I wanted you to be able to hear this if you missed it. So they're going to do two examples today. Here's the first one: the peppered moth. There are two colors of peppered moths. There's a light version and a dark version. And what color of moth? Think about it. What color of moth would you want to be if you lived in this forest? Now, not which moth, well, actually, let's say it this way: which type of moth coloration would be most successful in this forest? Because they don't get to choose what color they are, right? Their genetics determine that. And why would it be you would want to be the white one? Well, because you would have camouflage, and camouflage is really important in the natural environment. So if a predator comes by, which color moth is easier to see? It's definitely the dark colored moth is easier. Now, yes, they could land specifically. I always hear this, but they could just land on the dark spots. Well, let's think about it. Does a moth have the ability to think, well, I should land on that dark spot because I would be more camouflaged? No, that's not how things work in nature. Okay, so let's say you are a peppered moth in this environment. Which type of moth coloration would be more successful in this environment? Well, and again, this time it would be the dark colored moth because they would be camouflaged. So here you can see we had a hard time cutting out the moth there, but it would be dark in color, right? And it would blend in better with the trees and the branches. Okay. So there are four key principles, and we're going to use sea turtles. So that's why I'm wearing my sea turtles shirt today. I'm wearing my Sea Turtles Hospital t-shirt today because we're going to talk about sea turtles as our example today. And so the first thing that has to happen in order for natural selection to occur is that there has to be overproduction. And what this means is that an organism, when they produce more offspring than the environment can possibly handle. So, for example, this is a horseshoe crab. Oh, there we go. Horseshoe crab. Horseshoe crabs, one female in a mating season can lay 10,000 eggs, and about 100 of those will make it to an adult. Okay. So, what happens to all the others? Well, some die due to disease. Some are eaten by predators. Some just don't get enough food, whether maybe they're too slow and the food that they need to get to, they can't get to it. Or they're too slow and others of their species get there faster. Or maybe they have something wrong with their way they collect food. So some will die for those different reasons. So here's an example. Green sea turtles, okay, again, sea turtles lay 130 to 1,000 eggs in a nesting season. Okay. So that's one season. They can lay anywhere between 130 and 1,000 eggs. That's one female. Okay. 1 in 1,000 of those will actually survive to an adult. Okay. What happens to most of them? Well, eggs and hatchlings get eaten by seabirds, fish, crabs, and dogs. The adults the ones that are older get eaten by sharks and humpback whales. Okay, so you can imagine that most of them when they're small either as the egg form, right? Because think about how many eggs don't even make it. They don't ever hatch because they get trampled on the beach or something else digs them up and eats them before they hatch. So a lot of the eggs get eaten before they're even hatched. So after overproduction, so I did put a note sheet in the notes today, and I would expect that because you're gonna take notes today, so you're gonna want to write be writing this stuff down. You can go back, obviously. So variation within the species, there are natural differences in traits by mutations in the DNA. So if you look around our room and we were to line up everybody by height, like we talked about, the height would be very great. So there's variation, there's natural variations just because of changes in the DNA or changes that happen in organisms. So, for example, the coloration, maybe they get a letter change and it makes them a little darker, or a letter change, an A to a T or a C to an A, and they are lighter in color, and that helps them to blend in better, or they get more color. All of those things could help. So, example would be that green sea turtles might vary in the size of their shell, the color of their shell, the length of their beak or their mouth, and the size of their flippers. So, all of those ways are ways that they vary. Look at the difference in color in those two green sea turtles. I like both of those very much. I love turtles. I don't know if you know this, but I love turtles. Okay. So then the next step. So we've got they wake too many. There's variations in the population. Just naturally, there's variations. Okay. Now, when one of those variations becomes an advantage over the other organisms. So let's say that they have longer fins, and those longer fins allow them to swim faster. That is an advantage. So now that variation, the longer fin, is an adaptation because now they have gained something. They have an advantage due to that. So when one variation gives some organisms in the species an advantage over other organisms, that becomes an adaptation. So an adaptation is just a variation with an advantage. Okay? So some variations aren't an advantage and then they don't become an adaptation, right? Because that's not something that's important. So here, with green sea turtles, their larger flippers help them swim faster to escape predators. That's so sad right there. But that's what happens to a lot of them, or they get eaten by crabs. Okay? So that is not uncommon. Yeah. So then last, and this is the one where most students struggle, because what happens is this is saying what's going to be in the next generation. So when the adaptation allows the organisms to survive and reproduce and pass that trait on to the next generation. So this is about what are you going to find? So according to this, we're going to find more turtles with larger fins in the next generation, right? So we're going to see that these two turtles have babies because they have longer fins, and their babies are going to have longer fins, which then continues this process of adding more long-finned turtles into the next generation. And so that's all for today. And then make sure that you go back now and take some notes on this information so that you have it. So there's two ways you can do that. You can you can print out the note sheet, which is posted here, or you can just write on the note sheet that's here, I made a copy for you, or you can take a picture of your notes and send it to me. Okay, so the assignment for today is to take notes on this slideshow. Thank you. Have a good day, you guys.